Today's lesson looks at a new form of a line. It's called a general form. So we're going to do two things at once. We're going to use the general form to graph a line. We're going to write the equation in general form, and you're going to see general form has a couple of really good features. So for these example number one, what I want to do is I want to solve for y. I want to isolate y. And in isolating y, all of a sudden you should be thinking y equals mx plus b form. So let's go ahead and do that. In order to isolate y in the first one, we're going to have to subtract x and subtract 1. And we're going to have to do that from both sides. And when we do that, we got y equals negative x minus 1. And seeing as we have it written in mx plus b form, we know the slope is negative 1, and we know the y-intercept is 0, negative 1. So again, a very nice, nice way of writing it. This one right here is pretty much the same. One extra little step. We're going to get y by itself. We're going to subtract 3x and add 6 to both sides. And then what we get is negative 3. We get y is equal to negative 3x plus 6. And then we're going to divide everything by 5. And when we do that, we get y equals negative 3 over 5. X plus 6 over 5. And again, when we have something that looks like that, it's really easy to find the slope and the y-intercept quickly. So that's what we did. That's what we did the other day. And again, it is a really nice form of a line, but it gets a little bit more difficult when we have fractions. Now, I just want to remind you of algebraically how to find the x and y-intercept. To determine the y-intercept algebraically, we just plug in 0 for x and solve for y. And to determine the x-intercept of an equation algebraically, we do the same, except we plug in 0 for y. So we plug in a 0 for y and solve for x. And this is one of the things we want to know about lines. What's the slope? What's the x-intercept? What's the y-intercept? So for example number 2, I just want to review finding x and y-intercepts. In this case, just the x-intercept. The x-intercept is the one thing that slope-intercept form doesn't really do. So remember what we talked about before. If we're going to plug in 0 for y, the y stuff literally goes away. And when we go ahead and solve the resulting equation, it's really easy. And we get x is equal to negative 1. So negative 1 comma 0 is our x-intercept. Similarly, over here, all the y stuff disappears. 5 times 0 is 0. It literally goes away. And we go ahead and solve this simple equation. And we end up with x equals to 2. And again, our x-intercept is 2 comma 0. So when something is written in any form, we can just plug in zeros for x or y and solve for the x or y intercept. But this one, I hope you look at these two examples and go, well, that was pretty easy. The algebra was pretty easy, and that's one of the good things about writing an equation that looks like this. It really allows you to find the x and y intercepts without too much trouble. And this notation is called the general form. And here is the general form right here. You can't change it. It is what it is. And the general form of a line is always written in this way. X stuff first, B stuff, Y stuff second, and C represents a number, and it's all equal to 0. A, B, and C have to be integers. That is, they are nice numbers, no fractions. And A has to be positive. So all the examples you see below, examples 3, 4, and 5, they are all written in general form. Again, we have our x stuff, our y stuff, and our numbers, and there are no fractions, and the first thing, the x thing, is positive. And what I hope you see is It is super easy to find the x and y intercepts when you do it this way. And again, if we want to graph a line, we only need 2 points, but they do need to be nice. So in this one right here, again, when we find the x-intercept, the y stuff goes away, and I'm going to do that all in one step. Again, 3y, 3 times 0 is 0, so I'm not going to write it down. I'm going to subtract 12 from both sides, and I'm going to divide both sides by 2, and that would be my x-intercept. Remember, we plugged in a 0 for y, so when y is 0, x is 6, and I'm going to go ahead and I'm going to plot that, negative 6 comma 0. In order to find the y-intercept, we're going to do the same thing, except we're going to plug in a 0 for x, which literally means it goes away. And then we're going to solve this simple equation. We're going to subtract 12 from both sides. We're going to divide both sides by 3. Therefore, 0 comma negative 4 is my y-intercept. And I would go ahead and plot that. And if I wanted to draw this line, then that's all I would need to do. So again, you should be drawing your line. You should be drawing your line with a ruler. We could have taken the time to put it in y equals mx plus b form. We would have got a nice y-intercept. We would have known the slope, and we could have plotted. But this way is quick and easy and nice as well. If I asked you to find the slope of this line, well, what you could simply do is you could figure out the vertical and the horizontal distance, and this is going down 4, and this is right 6, so the slope is going to be negative 4 over 6, or negative 2/3. I didn't ask you to find that, but that was easy. That was easy to find the slope given the picture. Well, similarly, let's do this problem. And in this problem right here, our x-intercept is going to turn out to be, plug in a 0 for y, we're going to get 6x plus 4, minus 4, sorry. 6x minus 4 is equal to 0. We're going to add 4 to both sides, and we're going to divide both sides by 6, and we end up with a not nice x-intercept. It's not nice because it's not an integer. Now, you can't go ahead and graph that thing. You cannot plot 2/3. You're guessing. And again, I'm only allowing you to plot nice points. In order to figure out the y-intercept, plug in 0 for x. 6 times 0 is 0, and it goes away, and we just go ahead and solve this. We add 4 to both sides. We divide both sides by 2, and we get 0 comma 2. So I can plot that one. I could plot that one. So in order to graph this, I'm not going to go ahead and graph this one because it'll take a few seconds, but in order to graph this one, all you'd have to do is put it in y equals form. Put it in y equals form, then you could figure out the slope, and then you could plot another point, and the other point actually will be this one right here, 1 comma negative 1. So if you go ahead, you will figure out that the slope is negative 3, and use that to plot another nice point. And when you actually connect these two, it will look like our answer of 2/3 makes sense. Okay, so again, I said, let me make note of that, I said that the slope is negative 3 or negative 3 over 1. So finally, this last one. This last one, if you went ahead and found the x and the y-intercept, neither are going to be nice. So let me just make that note. Neither the x or y-intercept will be a nice point. And if you don't believe me, pause the video and figure it out, but they won't. So if you don't have a nice point, how can you go ahead and count the vertical, the horizontal? It'll involve fractions. It'll be tricky. But the other thing we could do is, in this one right here, we could put it in y equals mx plus b form. It wouldn't be a big deal. So if I were to put it in y equals mx plus b, I would add 3y to both sides. Because remember, I mentioned this the other lesson, when your y stuff is positive, I leave it alone, and when your y stuff is negative, I move it. So this one right here, that's what I would do. I would go ahead, it's not supposed to be next, right? I would go ahead and I would move my, y stuff over, and then I divide everything by 3, and here's the slope right here. So given that, my slope is equal to 8 over 3. Now, if you look at these 3 examples, the top slope was negative 2 over 3. The middle slope was negative 3, and this slope is 8 over 3. There's a pattern. So I'm going to give this to you. Normally I don't like to do this, but notice there's a pattern with respect to slope. With respect to slope. And here's the pattern. The slope is equal to the negative of a over b. If you go back and look at the number in front of x, that's the a, and the number in front of b, if you simply plug it into this little formula, you will see a shortcut. Of course, you can never go wrong by putting something in y equals mx plus b. It will find the slope for you. So that's a little shortcut. Be careful with shortcuts, though. Make sure you understand it or don't use it. You can always do it a little bit longer way. So one of the things that we just did is we went from general form to slope-intercept form, and that might be valuable to be able to do, because then you can find the slope if you had to. But the other thing you have to be able to do is to go backwards. You have to put something in general form. So here's our recipe. This is how you go from slope-intercept form to general form. It's a 2-step problem. The first thing is you get rid of fractions. Now, there might not be fractions, so you would skip this step. You get rid of fractions by multiplying everything by the LCD. And this is not like grade 8 math and grade 9 math where there was a big struggle to find the LCD. Usually the LCD is really easy to find. And usually there's only one fraction. And then the next step is you move everything onto one side so it's equal to 0. Move everything to one side, but again, in proper order. Has to be x, has to be y, has to be number, and the x cannot be negative. So let's just look at a quick couple of examples that we can do easily. I want to write the equations of line C and line E, and I want to write them in general form. So with line C, we see that it has a y-intercept of 4 and a slope of negative 2. I'll leave that for you to make sure you see that. But there's our y-intercept of 4, and there's our slope of negative 2. So in this example right here, there is no fraction, so we don't have to worry about part number 1. So in this one right here, we just have to put everything on one side. Now, remembering that the x stuff has to be positive, so in this case, the x is negative. I can't move the y over this side because then my x would be negative. So by the form, x has to be positive. So here's simply what we have to do. We have to move the 2x over, the negative 2x over by adding 2x, and we have to move the positive 4 over by adding 4. And again, we're going to do the same thing over here. And when we go ahead and do that, if I wrote it just like I have right here, I'd have 2x minus 4 plus y is equal to 0. And that's not right, because it is not in the right order. So we have to put the x stuff, the y stuff, and the number. And as long as you take the sign with it, so a plus y, and as long as you take a minus 4, you can move things around. So this becomes 2x plus y minus 4 equals 0. And that is in general form. No fractions, everything on one side equal to 0 in the proper order, and the x is positive. Information can slope-intercept form give you really quickly. And what it can give you really quickly is the slope and the y-intercept. Now, it can give you really quickly if it's in slope-intercept form. If it's not, you manipulate it and you get that information. Well, what information can general form give you relatively quickly? Well, relatively quickly, easily, it can give you the x-intercept and the y-intercept, but it can also give you the slope as well if you know the pattern. And finally then, if we know these two forms of a line, well, which form is better? And the only thing I can say is it depends. Depends on what's happening.